Welcome. Today's lesson is on section 6.5, and we're going to talk about the law of sines, which may or may not be familiar to you from your previous math course. So, the law of sines is essentially a law that can be used to solve any triangle. And I say that lightly. Basically, you could use it for a right triangle, so you could completely let go of SOHCAHTOA. So it could be any right triangle and or the following three cases down at the bottom. I would not say you need to memorize these. And I'll talk about why as we do a couple examples. The law of sines is used as ratios of the sine of an angle to its respective side. So for example, if you knew angle A and side A, you set up a proportion or a ratio, I should say, with those two sides. So those two pieces. Then if you know angle B side B or angle C side C, you can set up those ratios as well. So basically, if you know or if you know angle A information and angle B information and nothing about C, then you would just skip this. So you're going to be setting up a proportion to solve for like a missing side or a missing angle. The cases that work for law of sines are an angle side, and I just have a picture here if you're a visual person. So if I knew angle C, angle A, and side C, that's angle side. Angle side angle, so here's angle side angle. And the third case, which is probably the trickiest about the law of sines because it's ambiguous, is the side angle case. And the reason why it's ambiguous is because if you know two sides and an angle that's not in between it, it may create a triangle. It might not create a triangle at all. They just might not work with the pieces given. Or it could actually make two triangles. And I'm going to talk about all of those in this lesson. So I will put real high emphasis on number 3, the side angle. You do at least need to recognize that one for the ambiguous case. So if it helps, it's, the bad word spelled backwards, side angle. So that's the one you need to be cautious of. So I will come back to that as we look at some examples. I'm going to start with just a word problem and apply that to the law of sines. So two people who live 20 miles apart simultaneously look at an overhead airplane that is between them. The angle of elevation relative to the first person is 80 degrees. The angle of elevation relative to the second person is 15 degrees. What is the distance between the first person and the airplane? Okay, so obviously the first thing you need to do is visualize this. So the two people are 20 miles apart. They're looking up at an airplane. Okay, so I'm going to unveil this picture. Here's person 1, person 2 looking up at the airplane. They're 20 miles apart, right? Angle of elevation relative to the first person is 80 degrees. So remember that would be the horizontal and looking up. That creates 80. Angle of elevation of person 2 is 15 degrees. What is the distance between person 1 and the airplane? So I labeled that X. Okay, now if you're going to apply, so clearly this is not a right triangle. You cannot use SOHCAHTOA. But good news is we might be able to use the law of sines. I would, first of all, if you can use the law of sines, you have to have an angle and a side opposite for sure, because looking at these ratios, you have to have at least one of these completely. So for example, 15 degrees matches up with X. And I don't know X, so that's not helpful. 80 degrees matches up with, I don't know what this is. 20 miles matches up with an angle that I don't know, but I do know, because if this is 80 and this is 15, the triangle sum rule tells me this angle has to be 85 degrees. So now I know the airplane's angle and the side opposite. So let's just say this is angle A, then this would be side A. So I know this ratio, right? Okay, so sine of 85 degrees over 20, that's like my A information. It doesn't matter what you call A, B, or C, of course. Okay, then I need to solve for X, so I need to tie that in. So I'm going to do angle 15 with its opposite side X, so that's, say, maybe angle B. So sine of 15 over side B, which I called X. So make sure you understand where these ratios come from if you need to pause and think about that. Then it's just a proportion, so I just cross multiply. So 20 times sine of 15 equals x times sine of 85. Stop and make sure your calculator's in degree mode. All of this is in degrees. We're back to triangles. Okay, to solve for x, obviously I'm going to divide by sine of 85. So I'm going to dump this 20 times sine of 15 into my calculator, divide by sine of 85, and you get 5.2 miles. And you probably want to make sense of that. I mean, does it seem logical that a person is 5 miles from an airplane? Sure, I guess the airplane must be descending or ascending, but not very far above that person. Okay, so there's a basic application of law of sines, so a non-right triangle. But again, you can use law of sines for a right triangle as well. All right, I'm going to get into the ambiguous case because this one's a little more challenging. And the ambiguous case, I try to give you a visual. If you have, again, side-side angle, so blue is my given information. Okay, so side A, side B, angle A, side, side, angle. Okay, taking that same information, if I knew angle A, see over here, angle A is the same. Side B length, you can see is the same. And side A length is also the same. You can kind of tell that, right? So I can actually create two triangles with the same angle A, side A, and side B. Because notice this C and this C, C1, C2, are different, and as is angle C and angle C on the two triangles. So that's why it's called the ambiguous case, because if I only gave you side-side angle, you could figure out one triangle. You have to make sure that you check for the second triangle. The key to knowing if there's a second triangle right here, critical first step, is once you solve for the first triangle's angle, then you need to find its supplement. So notice B1 and B2, they are supplement angles. So if this was 30 degrees, then this is 150 degrees. Okay, that's going to be key in your process. And then finding the C information is just double. You just basically do law of sines twice. You have to do double the work. Okay, so I'm going to give you an example of this ambiguous case. So let's say you're given angle B is 31 degrees, side B is 8, and side A is 13. First of all, what triangle case is this? So if you visualize the triangle, focus on the blue for just a moment. I know side B is 8 and angle B is 31. And then I know side A is 13. I should have labeled this C. I have these backwards, but you can see regardless that this is side, side, angle. So this is the ambiguous case. And so when you're making that decision, you can rule out, you can't rule out. You need to make sure that you check for the possibility of a second triangle. So first step is just like the last example I did. So I know angle B and side B, so I can set up a ratio. Sine of 31 over 8, like B and B go together. Sine of angle A over side A, I have no other option. I have to incorporate the 13, right? So when you cross multiply, and this one's going to be a little bit different, but 13 times sine of 31 equals 8 times sine of A. And then I'm going to divide by 8. Okay, when you solve for an angle, and we talked about this in chapter 5, you have to do the inverse. So I'm going to do inverse sine of, I don't mean to have an A there, inverse sine of this 13 times sine of 31 divided by 8. Make sure, again, you're in degree mode because we're dealing with triangles. Dump that into your calculator, and you should get 57 degrees. Okay, so angle A, which is, let's see, this is my 13, so technically my angle A is labeled C. Again, sorry about the mislabel, but that should be 57 degrees. Well, notice the green now, this could be a possible second triangle, which means this angle C is way larger. I'm sorry, this angle C here. And so your side length of 8 is the same out here. And then, of course, your 13 and your 31. Like, you can't change this black fixed information, no, regardless of your first or second triangle. So here is, again, is critical first step. I had to find angle A. There was no other option. I need to find its supplement right away. Okay, so critical first step, right? Find that supplement. So 57 degrees is what I got. 180 minus 57, that's 123 degrees. So triangle 1 could have an angle of 57 for A. Triangle 2 has an angle of 123 degrees for A. Now, how do I know that this works? Well, find their third angles, right? B up here, 31 degrees, is fixed. So for both triangle 1 and triangle 2, 31 degrees is fixed. So if I take 31 plus 57, that's going to be 88. Subtract that from 180, and I know that angle C is 92. Do the same thing with the second triangle's angle A. 123 plus 31 is 154. Subtract that from 180, and I know that its other angle C is going to be, or its second triangle, angle C, will be 26 degrees. So now I have two completely different triangles, right? And again, you can see if angle A here, which this is technically my angle A, if this is 57, then the other angle A of 123 would be this angle C that I swung out there. And then you can see angle A here, and you can see angle A for the first triangle here. So now the only thing left, I have B and B, which is fixed. I have side A, which is fixed. I found both angle A's and both angle C's. So the only thing left is to find that third side C, which would be this side for the first triangle and this side for the second triangle. So I'll just do law of sines, right? So off to the side here, I'll start with my first triangle. If I do, I'm going to use my fixed information. You have options here, but I'm going to do sine of B over side B equals sine of angle C over side C, and then cross multiply. And solving for side C, so divide the sine of 31 over to the other side, and I get side C for the first triangle to be 15.5. Okay, same thing for the second triangle, set up another ratio. So these are just like double work, right? So I used B information again, sine of 31 over 8 equals sine of angle C for the second triangle over side C, cross multiply, and solve for side C. And the second triangle's side C is 6.8. So this is all of the second triangle information. This is all of the first triangle information. The black stuff goes with both. So in summary, here are your pieces. So triangle 1, triangle 2. Notice the first line of both triangles. That's the fixed given information, which can't change. And again, you can apply that up to this triangle if you're a visual person, just to kind of see how that works. So there you have it, ambiguous case. Again, once you set up your first ratio, there's only going to be one way to do that, and you find that first angle, figure out its supplement right away, and then that kind of sets up your two separate triangles. Okay, so ambiguous case might have just one triangle, it might have two, which I just covered. It also might not work at all. So I just very quickly want to give you an example of this. After you, the steps are here, but it's fairly straightforward because bottom line is you're going to get an error on your calculator. So that will kind of tell you like, hey, this just doesn't work. So if you know angle A, side B, again, this is a side angle case, right? So I know that I got to check for this ambiguous case. Maybe it works, maybe there's two triangles, maybe there are none. So if I set up law of sines, I can put my A information together for sure. So sine of 63 over 42, and then side B, so sine of angle B over 120. Okay, cross multiply. And I'm going to solve for angle B, so I need to inverse sine this quotient, right? So dump that into your calculator. I'll simplify that a bit. So I'm going to inverse sine. This is 2.55. You can't inverse sine a ratio larger than 1. So I already know based on this is not possible. If I, for just kind of going too quickly and I type that into my calculator, I'm going to get an error domain from my calculator, which tells me, hey, there is absolutely no triangle possible. So those probably the easiest ones you do because you get to stop. All right, so there you have all the information you need for the ambiguous case, which is probably, again, the most work. So on to our last example, just to make sure you're comfortable with word problems and kind of divvying up angles and whatnot. Okay, so you have a telephone pole on a hillside that casts a shadow 20 feet down the hill. Okay, so first of all, if you look at this picture, and I might have this picture drawn for you without any angles. So if it's casting a shadow 20 feet down the hillside, well, if this is the sun going and hitting the pole here, the shadow is going to be this piece on like the hillside, right? So this from B to C would be 20 feet. The angle of inclination of the hill is 37. Okay, so the green is your hill. Angle of inclination is just like an angle of elevation. It's a hill instead of a person. So that would be the difference. So here's my horizontal for the hill right here. And angle of inclination would be from of the hillside, sorry. So that would be just this little green angle here. And actually, I'm going to pull down 37 so you can kind of visualize that with me. So inclination of the hillside would be horizontal to the hillside. So that's 37. And then the angle of elevation of the sun from the horizontal to the top of the pole is 71 degrees. Okay, so 71 degrees now is the angle of elevation from the sun. So horizontal to the sun. That means this whole angle, I'm going to try to kind of put it in the middle, this whole angle is 71. So if the whole angle is 71 and this is 37, 71 minus 37 is 34. So that means this one is 34. So I'm going to kind of get rid of that 71 a little bit in the way, right? So 37, 34, because of this equaling 71 degrees. So that's probably the trickiest part, is just making sure you get everything placed correctly, of course. Otherwise, everything else, I mean, if I know this is a 90-degree angle and this is 37, then I know that this angle here needs to be 53 because these have to add up to 180, right? And then these 53 and this angle are supplementary. So 53 plus 127 equals 180. And then this triangle off the hillside, 34 plus 127 plus 19 would make 180. So you can fill in everything. You may not need to do that much, right? I'm just making sure you see everything. So you want to find the height of the pole. Okay, that is this brown pole, if you can see that here. So I'm going to just focus on the triangle that's out of the hillside, since that's what I want to find. And I'm going to give you a better picture here. So 20 degrees was the casted shadow. X is the height of the pole. That's what I want to find. And then the rest of the angles you can see because we put those together. So not a right triangle, cannot use SOHCAHTOA, but I can use law of sines because I have an angle and a side opposite. I have an angle and a side opposite that I want to find. So setting up law of sines, sine of 19 over 20 equals sine of 34 over x, and then cross multiply and divide by sine of 19 to get x, and you will get 34.5 feet for the length of the pole. So not too bad, just one more quick application. All right, at this point, you are done. I'm going to do one extra example here if you want to practice one on your own. So maybe pause the video, see if you can just solve the triangle. And remember, solve the triangle means find all of the pieces. So you know angle A, angle C, and side B. So you need to find side A, side C, and angle B. So give yourself a couple minutes and I will walk through it. All right, so if you notice, you know angle A and angle C, so then you also know angle B, because based on a triangle supplementary theorem, you know they have to add up to 180, so 170 plus 10. So now I have a match, side B, angle B. So I can set up law of sines. So sine of 150, that's A over A, sine of 10, B over B, cross multiply, divide by sine of 10, and you will get side A to be 575.9. So hopefully you got that. And then set up another ratio to find side C. Okay, so I paired my B's together again, side B and angle B here. and angle C, obviously, because I'm trying to find side C. Cross multiply, divide by sine of 10, and you should get 393.9. So that was, again, just an extra example. This is not the side-side angle case, right? Look at the original. So you did not need to check for a second triangle, just to clarify that. All right, there you have it. Law of sines. Have a wonderful day.